earlier. Welcome back. And for those who are new to it, Afterlabs is a platform with a vision to enable research without boundaries. So with the recent democratization of knowledge, particularly in ML and learning areas, we are seeing a huge um, crowd of young learners who want to learn stuff on their own and dig deep into stuff and play with tools and do research. They actually have enough information to do research. The goal of Often is to give a platform to them, mentor them, and connect senior researchers with young researchers so that they can target specific problems and dig deep into get a flavor of doing research. And research is not a purely academic activity. It has one of the ways to think about it. There's a lot of traits that are common to entrepreneurship and research, and you deal with uncertainty. You find out your own paths, and you learn a lot of grit when you start trying to solve these problems. So learning and training to do all of that is the goal of Afterlabs. And the AI Talk series, I guess some of you have already been part of it earlier. Our YouTube channel, if you search for Afterlabs, you will find the previous videos. There's a wide variety of videos from speech, NLP, search, biology, MLOps, a huge variety. We have had amazing speakers earlier. We invite industry experts and researchers and builders, practitioners to share who are passionate to share their knowledge, to talk about both cutting edge topics as well as their experience working in this field and how they have seen the field evolve, as well as what do they think good data scientists, traits of good data scientists are. And so we have had amazing set of talks earlier. And the talk is a sort of blend between a traditional presentation and a podcast, so we keep things free-flowing. Our audience can ask questions anytime, and yeah, we can have a very free-flow discussion. Our audience has been very technically engaged, and so this is in traditional days we had research lab talks, which were very engaging. So here we try to keep the format more open and more accessible to the broader engineering audience, and so that way we hope we can disseminate information about cutting edge research to more people and get them involved and able to answer the questions. Yeah, so that's the short introduction. We take delight in unraveling the experience of research and innovation, and we celebrate the innovators and the experts in the field. That's the goal behind these series. So, and today we have Aravind Ganapathiraju, who's Senior Director, Uniphore Data Science. We're very glad to have him today to talk about his experience in speech recognition and conversational AI from over a decade. He's seen the initial, like we were talking, the initial VAD, voice activity detection systems, to the more recent deployed transformer system, for example. So we are very happy to have him and share his knowledge, building these systems, teams which do research and take research to production, and lots of practical aspects of actually making these things work. So thank you, Aravind, for agreeing to give this talk.
Thanks for having me.
Yeah, and over to you. Yeah, please. Let me just quickly inform the audience. The AirMeet platform is, as you can see, a bunch of tabs on the right hand side. The chats tab is where you can drop in your questions, and I will relay them to Aravind periodically. Aravind could also see them and choose to answer when he likes. And if you want to talk and answer and ask a question, you can click on the raised hand, and I'll give you the mic. But as in previous sessions, people it gets really busy and people have lots of questions. So feel free to use the chat box as much as you want to ask your questions. And there's a video that I've put in from the introduction to Afterlabs. You want to watch it at some point to learn more. Yeah. Okay. Thank you, Aravind, again, and please over to you. Yeah.
Thanks, Nishant. Really love this idea of tech talks. Not necessarily, in-depth tech talks. Obviously, there are publications for that, but sometimes hearing the nitty-gritty from the practitioners adds a lot of value. On a daily basis, I get on my soapbox and tell my team members that the attention to detail on the simplest things is what can make or break a conversational AI system. So this talk is generally my experience of how conversational AI is being used today, the challenges in the various aspects of conversational AI, things that we as researchers have to solve, and things that enterprises still are not very diligent about. And I'll get to it. Like for ASR, if you have poor audio quality, even though you had a choice to get better audio quality, why wouldn't you do that? But as a enterprise, not every enterprise, in our case, we deal with BPOs and contact centers, so for them that's not of importance. If a human can understand it during audit, why can't a system understand? That's their argument, which is fair. We'll eventually get there, but today that poses a challenge. So hopefully through my talk you will just get a view of all the aspects that you may have to look at to make systems successful. At Uniphore, I head the data science team, doing NLP, ASR, and all the other ancillary aspects of conversational AI. So what I did was just to see, what do people think about conversational AI. I just literally took the top 20 hits with my Google search on what is conversational AI and created a word cloud. Pretty interesting what you find. First thing is it deals with human conversation. And the other nice thing that came out was it is a set of technologies. I think a lot of times, like when we talk about ASR or NLP, it's generally we are very focused on one neural net or one transformer, whereas reality is conversational AI is an agglomeration of several technologies. It was really nice to see the speech and voice showing prominence there, and there are significantly more challenges with speech and voice compared to text, which we all as practitioners we know what those challenges are. Natural language processing is a big pillar on which conversational AI stands. Conversational AI is not complete without languages, because as humans, obviously, we deal with languages day in and day out. Most of us are, multilingual in our daily lives, and that shows in, in real world enterprise use cases. For example, when we call to the Airtels or the Axis banks of the world and choose English as a language or Hindi as a language, I can bet that most of us very fluently switch between Hindi colloquialism or English colloquialism in our conversations. Many times you'll see people say, speak very fluently in English and end the call with "theek hai" or "chalo." Obviously, these are not English words, yet the ASR system is supposed to deal with that. So there is also that complexity beyond just the complexity of having conversational AI deal with a specific language. Another important aspect of conversational AI is in the bots world, be it voice bots, chat bots, and the primary need for those bots is detecting intent or tracking intent. So that also forms a big part of conversational AI. And Obviously, all this is being powered by machine learning of various kinds, to the simplest, regular expressions or keyword searches, which is also machine learning, to the more fancy transformers that we have been talking about for the past 2-3 years. So why this excitement for conversational AI? So this is just a bit of my business personality talking about this, but I think it's important for us as researchers also to pay attention to this, because this is what finally drives business and our eventually our research minds. Small and large, there's tons of companies that are interested in this, in a share of the pie for conversational AI. Quick search on Gartner shows that conversational AI market just by itself would be about 13 billion by 2025. So that's purely the business standpoint. Coming to just the technology, why this explosion in interest for conversational AI now? That's definitely because of the advances in ASR and NLP over the past few years. I remember in '95 when I started my graduate study, TI digits was the corpus, and I don't think anyone even knows or talks about that anymore. So purely just entering digits and system recognizing it. That's all was needed for an ASR system at that point, compared to the Alexas of the world today that just seamlessly seem to recognize extremely large vocabularies, to the insights that we can get from large conversations, be it in contact centers or the closed captioning that may happen. Huge advancements, and it's been a real pleasure to see that progression in the field that I'm passionate in. um, uh, I also had the opportunity to work as a transcriber during my graduate days on Switchboard, which was really something that spurned this research for conversational or large vocabulary speech recognition. Um, from there to today, dealing with song names that may be in millions with very high accuracies, how technology has evolved is in some sense pretty mind-boggling. Yet there is still a long ways to go. We know that because as technology advances, the use cases are actually a step ahead. The market and the businesses want something a little more than what they have today, which would uh, put more pressure on current accuracies and spurn more research. The transformers absolutely have just supercharged NLP. It has become just so easy to start with BERT, go to whatever classification problem that you have, and get more than reasonable results on day one. Data hasn't become such a big hurdle anymore, because the transformers, the pre-trained ones, obviously have seen gobs of data. With all that excitement, again, we have to temper that with, as new languages are being explored, the performance of these transformers taper down quite significantly, I would say, beyond the top 5 languages. The other thing that has really brought more excitement to our field is just the use of GPUs. Uh, I remember the first uh, LVCSR experiment, a 10-second utterance from switchboard in the public domain recognizer that we had built at Mississippi State, took us about 12 minutes. This was on a Sunspark, and we were thrilled that this it, yeah, that something came out and it was half reasonable output. From there to today, just expecting instantaneous
Almost
output.
correct.
is just amazing. I would say so. Uh, that's why I'm saying it. More than anything, it's just been a pleasure being a part of that journey for over 2 decades now.
So quickly, I have two questions coming. One is that in terms of collecting these data sets, starting from Switchboard or Fissure or Timid, I'm feeling that the community has been a bit reticent in collecting data and transcriptions compared to maybe Vision or NLP communities. Do you think so, uh, or what is the reason behind it? Uh,
The answer to the first question is definitely yes. I'm not entirely sure what the reason is, but a lot of it, to me, at least from my vantage point, feels like just privacy issues. We're just not able to get past that privacy issue. For example, if I really want to throw, I don't know, 10,000 hours of contact center data into the public domain, technically, that is literally I don't know, less than a week's worth of data that goes through our system in a large contact center. Now, why that cannot be released to the public domain obviously has privacy issues, and legality has just put a hard brake on that process. Unlike Vision, so the data, for example, obviously we can take YouTube audio or any of the online audio, and with appropriate licensing we can obviously release that data, but that's still not fundamentally domain specific data or data that can egg the research along faster. So that, yeah, and I'll talk a little bit about that as well, just challenges with data.
Yeah, yeah. I'd like to know more where exactly in the privacy spectrum it really hurts, or which they have been. But at a later point, you can. The other question is, in this period of say 20 years, where has it been a continuous improvement in performance, or there was according to your viewpoint, there was a sudden change, a very abrupt, disruptive change that happened, and obviously last 3 years we know, but even before that.
Yeah. Yeah, no, great question. I think it has been disruptive. For me, I feel like just Kaldi with its hybrid approach, in 2015 or whenever, they came up with, that really, put it over the hump. Until then, it was data was king with all our HMM based systems. The more data we had and more complexity our compute infrastructure could handle, uh, whoever could do that had more power. Whereas with Kaldi, I think the whole TDNN, I vectors, just that combination just clicked, where you could, even on switchboard, where we were struggling for several years in the 20-25% word error rate, that just suddenly dropped to a point where it was scarily getting close to human error rates.
Yes.
And it didn't require like the full-fledged end-to-end neural models for that. And it also, I guess, reduced the pressure on them on need for just large volumes of data.
Sure. Okay, and Caldi has been around since 2006 or 2007, but the change happened. Is that right? Or
Yeah, yeah. It has been around, but it was still, it's similar to Sphinx at that point in the initial go. Their, innovation at that time more was on the adaptation side, be it the speaker adaptation, MMI, and so on. But I think this combination of going from GMMs to TDNNs and having those recipes out there is what really powered this on.
Yeah, so it's connecting back to the audience. Some of you might be very familiar with speech ASR, automatic speech recognition systems, and conversational, intents and chatbots and dialogue managers. Others might be less familiar. So what we have been talking about is the history of ASR and this very popular tool called Caldi, and that tool has been, I think, one of the premier open source agents for pushing the performance of ASR even before the whole neural network bandwagon started. and incorporated neural network stuff also. And there's tons of improvement. There's tons of small details. If you're familiar with NLP or vision, like you have resonance and 100 variants of it and 100 different variants of training and how do you model. And there's a similar story in the speech domain too. So yeah, I mean, if you are less familiar, I request you to read more about Carl D, for example. And then,
Yeah.
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 And
And
also,
yes.
sorry, I may, for the audience, it's a very interactive place. Please, we know that it's a virtual medium, but please feel free to type in your questions in the chat box. And yeah, I think there is one question already. But Arvind, please, sorry, I interrupted you. Yeah.
No, I was just, just trying to finish this, the motivation for, or not motivation, why this excitement. I think just the familiarity with the success of voice in our daily lives also makes choosing voice as a medium to interact with automated agents a lot more easier. A lot of times in the early years, if, for example, AT&T has been at IVR, ASR powered IVR for a very long time, probably even close to 3 decades, I think.
Yes.
But the uptick was just low. The reason being that confidence level for people that when I talk to a computer, it'll actually do useful stuff was just not there because it was a very narrow domain in which it was being used. Whereas today, as a end consumer, we are just so comfortable using Alexa and Google and Siri that when in the enterprise world we encounter one of these virtual assistants, just natural for us to be okay with that. I think that acceptance also matters, because that means that businesses see that the 13 billion market because of that acceptance. I think if that acceptance weren't there, it is hard to justify how expensive some of these technologies can get.
Right. So the trust in the system has
Yeah.
improved dramatically.
Yeah. And lastly, there's something that's not often talked about, but just the possibilities for contextualization and personalization has really increased. So now instead of just thinking of this as give me speech, I'll try to get some insights for you. Now we are actually able to tie the context that comes from the CRMs of the world or the ERPs or any of these large backend data warehouses. That really makes the experience and the power of what can be achieved just massive. That was also missing in a lot of the previous generation use cases. They were very direct. You say this, you get this, system response. That's it. Whereas now it is like you say this, or you, yeah, we were in some pilots where the moment you call into a contact center, without even the contact center or the audio hitting the ASR, you've already gained so much information about the user because now you can say, oh yeah, the number that now this phone call is coming from is XYZ, belongs to Arvind. We had emailed Arvind about this great offer 4 days back. Most probably he's going to talk about this. We have already primed a whole world for ASR and NLP based on that previous history.
Yes.
That connection was missing for the past few decades, I would say. Now it's feasible. Obviously, the CRMs, even the smallest mom and pop shops rely on CRMs that just obviously you can see the success of Zoho and Oracle and all these guys. And part of the reason is everyone uses it. We know there is information there. Now we can actually marry these two technologies, the whole CRM world for providing us context and history, and the instantaneous recognition and classification and all that conversational AI can provide, and just have an amazing user experience where sometimes you'll just be blown away by oh, I didn't realize that I didn't tell them why I called, but it already asked me, can I help you with your balance transfer? Like how, but obviously it's not as much machine learning, but it's truly just contextualization and personalizing your experience, I think, is a big deal.
Yeah. Okay, that's a great point.
Then obviously you'll see why this excitement. You'll see all these headlines. Uniphore recently raised a huge round. Yeah, observe these are all Indian companies raising massive rounds of funding, which clearly vindicates and validates the potential. I think ASAP, that's another. They started as a ASR vendor, but now they've expanded to other areas. And just look at that massive valuation. I mean, $1 billion valuation for anything speech other than nuance would have been very rare 2 decades back. And in fact, that's another, just uh, off topic, but I always wonder why nuance, with its massive grip on the worldwide speech and NLP market potentially, why that didn't uh,
Yeah, the
grow
leader.
into something bigger, right? I mean, they should have been the Google of conversational AI.
Yes.
Uh,
That's a question I have also wanted to ask. Yeah. So, what do you think?
I don't know. It just could all. I mean, it's hard to say, but I was part of competing with Nuance. So as a
Yes.
startup in Converse, that was my first job out of after my PhD, and we competed with Nuance. Just the underselling, the pricing, etc. They would win there rather than the technology, and they would just buy competition. Voice signal was really cutting edge technology at that point. This was like early 2000s, and they bought that, but they never knew how to integrate that into their overall pipeline, because by then Dragon, naturally speaking, was a big deal for Nuance, and they had bought Dragon itself. And then now comes voice signal. How do you take that speech infrastructure and put it into the Dragon ecosystem? They couldn't figure out. So it just buying technology obviously doesn't get you to your vision. It'll still look very Frankenstein like. On the other hand, where the Googles and the Amazons of the world succeeded was truly ground up. They actually made sure that the use cases uh, were under their control. For example, Amazon, the use case for them is their own contact center. They became the biggest online retail player in the world, so they had to innovate for their own efficiency. They vetted out all the details of what is needed, then they pushed it out, as a service. So that flow is very different than this buy stuff, put it together, integrate, along with buying technology, you get people, but all cultures are not the same. So that doesn't fly out. And now nuance. If you see people moving around the big tech in this research space, you'll see them move from Google to Microsoft to Amazon. This is the triumvirate. Nuance doesn't, form a part of it. Of course, now it is part of Microsoft, but it met its, I guess, eventual death in some sense. But
Yeah.
it's very interesting that someone who can be that big for that long just couldn't capitalize on the next generation.
Yeah, that's very interesting. And perhaps the the way enterprises are built and traditionally built and run, maybe even now, is that the from if I had to summarize what you said, the flaw lies somewhere there, instead of being more agile or more caring about the customer or something.
Yeah, but that's definitely a possibility. I think any company that can that has the benefit of also consuming their own services definitely will do better. That's one of the powers of Amazon, is they can consume what they build first, and which means they will make sure it's done right.
I see.
Uh, I'll quickly go over the typical conversational AI use cases. It's a very vast field, as we talked about. So there's just the vanilla conversational IVR. What does that mean? IVR normally means you press a button you get to a certain point in the menu, you press the next button, you get to the next point, you enter information that through a keypad, and your task is complete. Obviously, the press button thing cannot happen if you want to uh, work with either smartphones or be hands free while you're driving, etc. So the conversational side had to come in. So now you could say, the system would say, press or say one for English, and two for Spanish or whatever, and you just say Spanish, and you get into the Spanish queue in the contact center. And there you can say, briefly describe what your problem is. You'll say, I'd like to reset my password. So you detect that intent, go to a particular node in the IVR, and follow the next instruction there. Very simple, well directed dialogue. There is no room for jumping around these nodes. If you get stuck in one node, you are forced to go back to the parent node. That's the experience that we have all dealt with and we still deal with. Many times I call into, especially airlines, and I just keep pressing zero or star till I get to where I want to, or till I get to an agent, because either it's urgent or I don't like to deal with their self-serve options and so on, right? Conversational AI just changes that. I still don't understand why airlines don't do a better job of self-service, and especially given that changing an IVR, a basic IVR into conversational IVR is very, very straightforward. I mean, uh, you don't need dialogue state tracking because there's no jumping around these nodes. You know exactly where you are, and it's just directed. It's You don't need dynamic TTS. You can just have prompts to speak out what needs to be spoken in each point in the uh, dialogue, and that's done. Yet it's still, we are still evolving, especially in US it's a lot more prevalent, but in India we're still evolving to that. And then we have all used chatbots and voice bots, more chatbots I would say than voice bots, because of just the complexity of voice, where a mistake is less, or I guess more deadly for the user experience. If you misrecognize and take them down the wrong path, the user experience just suffers. And then there is agent assistance. By the way, the highlighted use cases are the ones that we at Uniphore deal with on a daily basis. So agent assistance is where, when a conversation happens between customer and an agent in a contact center, the AI can help guide the agent with lots of things. It can help them summarize the call. It can help them uh, be, I guess, very or give very well defined responses rather than random responses, which makes it look a lot more professional. And then note taking. I don't know how many of you have actually been at a contact center, but if you go to a live contact center, a lot of times what happens is, we'll have a big monitor, notepad, post-its, whatever accessible to the agent. As soon as the call is happening, they keep taking notes. They don't type it up in a CRM immediately. They take notes elsewhere. It could be a notepad, whatever means they are comfortable with. Then they're supposed to collate all that and create a nice summary of that interaction and next steps and any promises that they've made, etc. All these need to be captured, put it into the CRM so something else can take care of it. What, however, happens given the uh, pricing nature of these contact centers is, they get paid by the hour, by the number of calls that they attend. So they'll not spend any time on note taking or pretty summaries. They'll just take the bare minimum, go with it. They take the next call and the next call and next call. Suddenly they look at their watch and it's time for lunch. Now in 5 minutes they have to finish summarizing 6 calls. So they do a very sloppy job of that and stick it into the CRM. From the CRM side, let's say you are using Salesforce and you want to use their Einstein AI for getting some insights on these calls. Guess what? With crappy input, the insights are all crappy, and then you think that it's probably the AI side that was suffering. Reality is just the data itself was poorly authored. So, our job here with agent assistance is how do we help agents do a better job with that? How can we summarize better than agents? And this is not abstractive summarization. This is, we are currently anyway still doing very template based summaries. The nice thing with template based summaries is slicing and dicing that data is really easy. You can really do a lot of in-depth analysis and analytics on that kind of data.
So what is a template-based summary? It's not also extractive, like selecting sentences.
Correct. So it's a bit of extractive and then a lot of entity extraction.
I see.
So, combination of intents and entities and putting it into a structure that the business defines for us.
And the output is natural language, or it's some
text.
JSON form?
It's all in JSON form.
Okay. And going from if we want to make it better, you have to go from the audio recordings of the chats to the summary, right?
Correct.
And that seems to be a very tough task, given the number of things intermediate.
Yeah, so that's the other challenge is, if you look at a lot of summarization demos out there, it's typically you give a paragraph, it summarizes.
Yeah.
But when you think about a call, especially if it's a troubleshooting call, that call could go on for an hour. And what are the reliable, islands of certainty, as they call, in that during that conversation? Identifying that itself is a hard piece. How do you do the call sectioning where basic just the greetings happen, followed by information extraction that is necessary or mandatory, followed by detecting the problem, troubleshooting the problem, resolving, right? Just detecting the sequence and where what starts is itself a research problem that's still in very nascent stages of evolution.
Right. So segmentation is the
call segmentation.
Yeah. So segmentation, I mean, again, in terms of papers, there are hundreds of papers, but in terms of reality, where is it? I mean, that would be, I assume, the first step after you get all the text.
Correct.
If you want to process. So is it part of? Is it like VAD? It's always part of, and it works decently, or not?
Yeah. So it works quite decently, but it's very data driven, and the challenge is how do you do the sampling of your customer calls to get the right data into your modeling part. Are all calls following a similar pattern is a hard thing to say, because it's very contact center specific. For example, you go to an American Express, if you're an American Express customer and you call them, they're like a premium brand. Therefore, you'll see that the agents are very methodical. They will listen to you. They'll not talk over what you're talking, and they'll explain things really nicely. Whereas you call some other contact center and it's all over the place. Recently I was just listening to a few sample Byju's calls, where these guys are doing a post interaction survey of XYZ visited you, described all these things. Are you interested in signing on to buy whatever the Byju's program is? But the contact center is just very unprofessional. What that means is the call can go any direction, and just the models to learn that kind of randomness is very hard. That's where the challenge is.
Yeah. So setting up the templates, probably some more inductive bias. This is structure, or these are different kinds of structure, and learn just them rather than just learning from free flow conversation.
Correct. Yeah. So again, this is where the engineering play comes in, where we can actually say, why don't we have an interface in the agent dashboard where their job is very simple. The system will say you are in this segment. So think of it as like in active learning, we have a basic model. The system is saying you are in the troubleshooting phase, and it will just highlight troubleshooting there. If it is wrong, the agent is asked to fix that for us. And then you go on to the next segment. We'll again, estimate where the transition happened from one segment to another. It will show something else. Agent can correct it or not. So there's instantaneous feedback, and you're actively learning. So So you can still at least do that. But if you just assume that someone will give you a bunch of data with all these nice labels and very well formed conversations, then it'll be a while before that makes it into mainstream. So there is no shame in going with these explicit methods. Pushing a button on a screen is okay till AI evolves, right? But not everyone does that, and that just slows down adoption, in my opinion.
Yeah, so that's so getting familiar with AI. That's an important message to everybody who wants to build real systems.
Correct.
Keep it explicit until AI can handle it.
Yeah, yeah. Yeah, and then there are the virtual assistants, the the Siris and the Alexas of the world. Where conversational AI plays a big role, because they also they actually have a conversation when things don't work. So you say something, they may respond back saying, "Couldn't understand. Could you repeat?" Or found several examples of this. Which one did you mean? So at least they have a back and forth with the human, where conversational AI plays a big role. And then there is interaction analytics, which is the more traditional, speech analytics, where all the calls are done. End of the week or end of the day, you want to look at all these calls at a macro level to dig deeper, to see, show me all the calls where the customer satisfaction score was less than 4, let's say. Or show me all the calls where Arvind was the agent, customer satisfaction was less than 4, and sentiment was low. Let's say you wanted to search for that. So that kind of an interactive dashboard would require what is called interaction analytics, because you have done speech recognition, you have done NLP, and you have saved all this metadata in a format where you can do all sorts of interesting visualizations and mining and searchability. So these three that I highlighted is where Uniphore generally plays a role. There are new areas we are always expanding into. For example, how conversational AI and RPA can fit into each other. So you do your speech recognition, you get your intent, and then hand over to process automation, where it will immediately send you an email or a SMS with a link to click on. That click will get registered somewhere, and a password gets reset. Let's say that's the process. So that's like a real nice one-stop shop for end-to-end process automation, and but which has been initiated by a conversation. So that's also something that our products are evolving towards.
Yeah. So a couple of questions are there. I'm just going to pick some of them. What word error rate for data coming from call center or BPA environment should be achieved for practical purposes?
Yeah, so typically what we are seeing is any word error rate worse than 30% is just not going to fly for gaining insights, or just because the keywords are not recognized consistently enough. So any rules that you may have, or any of the classifiers that you may have built based on nicely human transcribed data, will all just fall flat on their face. So I would say, just from my personal experience, 30% would be the absolute minimum threshold, or the maximum, I should say.
And you're talking about summarization. Uh, how do you evaluate the summarization system that you talk about? That's a very hard question. I don't think there are good solutions, but yeah, do you have any?
Yes. So from a business standpoint, for us, there is only one metric, which is how many summaries were accepted by the agent at the end of their call. What percentage of them? If you can hit anywhere from 60 to 80%, then you have done your job, and there has been good return on investment on this technology. That's how we look at it, because then the human has basically 60% of the times the human was freed of the need to write a summary, and which means 60% of the calls definitely will be very methodical, and then the insights will obviously show that quality.
Yeah, so it seems that there's a human in the loop to
Correct. And
label
in fact, the human is the creator of the data also. That actually helps. So it's not like a third party who's going to do that. Because agents also get dinged for in audits. If the quality of the summaries are bad, then the audit will show that you were presented the option of fixing it, yet you didn't. Therefore, you will get slapped on your wrist for being negligent. So there is an immediate feedback for them not paying attention to what AI is surfacing for them.
I think conversational systems, the chatbots in the deployment, plus conversation plus the contact centers are a unique case where there is human involved from the initial deployment, and
Correct.
it's always so they are naturally get the advantage of active labeling.
Correct. So that active labeling and active learning is a lot more feasible for these use cases. Definitely.
Yeah, quickly, how do you, okay, now questions. How do you overcome the challenges in low resource languages? That's one question. Other question is data scientists. Column. What is the cutting point where a data science hands over? The question is, what is the transition point where a data scientist hands the developed solution over to delivery readiness?
So I'll answer that second question first. The multilingual part, we'll talk about some ASR challenges later, so I'll cover it there. The handling the delivery, there has been a transition in how we work. In the past, if anyone has followed the Microsoft approach, where there is something called MSR, which is Microsoft Research. They'll develop the algorithms, do all the heavy lifting in terms of just coming up with the solution, data curation, all these things, right? And then they would immediately hand it over to engineering, where product managers would come in, design thinking, all that flow would happen, and the eventual product would come out. So now it has changed, since even at my previous job at Genesys, um, the data science teams themselves are owning services end to end. The reason for that is the planning of what it takes to develop the algorithm and incrementally improve it. Data science team knows best. Whereas if you just hand over incremental stuff to the engineering team, with them not knowing the vision of where you are headed, APIs will get defined that may not be future proof, or they may not have thought about how the volume of the data that they need to log at any point in time. So things like that, if it is not very well thought out, which happens best with data scientists, it becomes hard to manage and scale. So now the trend has become that we are owning our own microservices. For example, when we develop sentiment analysis, the typical life cycle is we identify the problem, come up with acceptance criteria and basic requirements like which languages are we targeting, does it have to be language agnostic or not, and so on. We come up with all that, get into algorithm research, prove to ourselves that we are ready to go. In the meantime, we work with engineers within the data science team to come up with the microservice architecture and the API contracts, and then that team, because it's already lockstep with the researchers within data science, will be responsible for delivering, scaling everything. Hope that answers. So it's definitely made that transition that I would encourage all data scientists or the people interested in this area to definitely not think of DevOps and microservices and programming as an alien thing. You better, accept the fact that the train has started moving in that direction, and we have to be on board.
I think this is a moment where we should play just music to wake up everybody who's on the call. And yeah, so if you're not dealing with or decent level knowledgeable about the engineering aspects, you might be left behind. Is that
Yeah, absolutely, absolutely.
okay?
Yeah, so this trend used to be there in the past where, before Python, etc., there would be many really, really good scientists who are only familiar with MATLAB or Mathematica. Uh, and in those days, it was okay because there were really specific teams doing the science and the development. These were two different things. Now that just will not fly. You have to be proficient in Python for sure, as well as at least basic knowledge of one of the cloud platforms, as well as microservice architecture. Without that, it's just hard to fit into any production level data science teams.
And it is a reasonably hard learning curve, right? I mean, people who want to adapt also are, they have delivery pressures, plus they have to learn on the fly. I mean, I
Yeah,
don't think
yeah, absolutely. The thing is, if you don't push yourself to learn that, then you don't appreciate the complexities at both ends, right? You may want to say that, hey, I came up with this great algorithm. I won my Kaggle competition using whatever, the largest bird that's possible there. If you don't know how that is going to be used while you're doing your research, you'll not even think about why not try Distilbird, why not try transfer learning to a much simpler network. You'll not even know that because you haven't put your mind into what the engineering side will have to deal with this giant elephant that you threw at them.
no.
Quickly, just glance over this. From a very high level, conversational AI is, the components are very simple. When you have voice, you generally do automatic speech ASR first, get the text, go into NLU world where intents and entities are discovered, which is where the comprehending or comprehension is happening. That's why Amazon, their service is called AWS Comprehend for that very reason. And then there is dialogue management and NLG for natural language generation, text to speech, and voice output. So this is at a high level what happens in conversational AI. Different use cases have obviously slightly different pieces. When I say natural language understanding, you can throw sentiment into that, at least in this picture, even though it's slightly different. I'll not spend too much time on this. I think it's quite obvious that even in the past 15-20 minutes, we have mentioned ASR and NLP a lot, which means those are the two definite big pillars. We are kind of ignoring text to speech for now, even though it has had its journey of evolution as well. I personally have worked on text to speech too, where from very synthetic sounding speech to very natural, we have evolved to very naturally sounding speech that doesn't require too much tuning. Now we are even seeing progress in the world of speech morphing, where with 10 minutes of speech you can have Modi like speech be generated. So there's a lot of evolution there. We don't deal with that at the Uniphore, and that's why I'm ignoring it. But something to, if people are inclined to, they should definitely also pay attention to text to speech.
And practical text to speech is slightly ahead of ASR. Is that a fair comment or no?
Yeah, yeah, definitely yes.
Okay, sounds good. Yeah, there are a
Okay.
couple of questions, but please. So we have about 20, 30 minutes now, depending on when. Yeah, so please.
Yeah, sounds good. So let me quickly go over this NLP side. I know, similar to Vision, NLP receives a lot of publicity, so to speak. So I just want to quickly cover what is uh, typically dealt with when we say NLP. There is sentiment analysis, natural language understanding, which does the entity or the intent extraction. Then there is explicitly entity extraction, or NER as it is said, commonly referred to as summarization, dependency parsing, dialogue state tracking, information retrieval, and then context and personalization I talked about earlier. Now, what actually allowed for a lot of progress in all these fields that I talked about is just the deep learning explosion that we have seen in the past decade. That's truly been a game changer, because we could now throw data or quantities of data at these systems that we couldn't imagine in the past. Transformers and this whole sequence to sequence models, etc., have really supercharged applications. We're able to think about new ways to use this technology a lot faster and a lot quicker than in the past. Uh, Transformers could be trained for one thing, but through transfer learning, we can make new applications feasible rather easily. That's also been really nice advancement in the technology. The availability of these multilingual open source models also allows for growth in new languages. I think this was one of the questions that was asked earlier, even though it was ASR specific. I think in general, more than ASR, NLP, the availability of multilingual models that have been trained on a lot of languages has really become reality in the past 2 years. A lot of times you can start with the multilingual transformer, throw a limited amount of language specific data, and come up with very functional models that can deal with NLP challenges. And also this, just the open source community has really taken off for new languages. I would still say language development focus has been probably in the top 20 languages. And as we know, eventually we'll have to get to hundreds of languages to truly make conversational AI a worldwide presence. But for those 20 languages, I would say there is a lot more data available now than in the past. And a big part of that is just involvement of the various governments to spur research along. For Indic languages, very specifically, we can see Government of India and even local governments really pushing hard for large corpora. I'll talk a little bit about that later, but the challenges that we are seeing from the IITs of the world, or the triple ITs, and more recently like Navana Tech, etc. Those are also really encouraging development of larger corpora that can be available for the research community. So it's definitely not as big a problem to get the baseline models going anymore. I'll quickly talk about at least few of these NLP topics and their challenges. The reason being, these are often misunderstood. For example, sentiment analysis. It's a very, it makes for a very sexy demo, as they say. It's very hyped, but in reality, I see very limited use for it, especially in conversations. Most of sentiment models have been trained on customer reviews that are very dense in information. So there's just one sentence, you say something, you're done. For example, you bought a TV, love the TV, great features, whatever, bright screen, let's say. That's what you said. It's all very straightforward, done in 20 words. Whereas think of trying to do that sentiment extraction over a 1 hour call. If you think of every minute you speak, I don't know, maybe 50 words, let's say, then 50 word, or like even 20 words, 20 minutes, 20 times 60, about 1200 words is what you get. In that, you need to now detect sentiment. The sentiment may in many cases change over time. In different segments of the call, it could be different. Now, how do you use all that information reasonably to actually gain insight on the call? That's not very well thought out. In demos, they'll just show oh, here's an angry customer and he said, use the F word at the agent, therefore it must be a bad call, let's flag it, right? This is what demos are today. Reality is just far from that. For example, we do a really bad job with our models on sarcasm. There's a lot of research on sarcasm, but not, it's a really hard problem and it's very language dependent also. Then there is negation, which we are really poor at. Co-references also matter, and that's also a challenge. And we don't have to really work to create new examples uh, to show these challenges. You can, go try these out on, any of the demo pages for Allen NLP or any of the transformer based sentiment analysis systems, and you'll clearly see in the before you hit the third or fourth example, you can trick the system. So, lot of room for growth and improvements on the research side there, and also thinking the big picture. Uh, Being pigeonholed because of the data that was made available for a very particular use case, we should kind of move away from this review based sentiment analysis. It has its place for that particular use case, but it doesn't really translate well to all the other conversational AI use cases, for which we'll definitely need a new set of corpora.
Yeah, I think a fundamental problem between what is NLP, even though people think that convert speech to text and then pick up the standard NLP pipeline, the text that you get is not even structured as a written text. It has repeated words. It has its own format distribution, and I'm not sure if and to label that kind of text or to transform it to the usual kind of NLP text, I'm not sure anybody or much work has been done there.
Correct.
So labeling this new kind of text is hard. I mean, you have to again bring the same amount of annotation or work to this spoken text. So yeah, so what is the status of it?
Yeah, so at least that's one of the reasons that it hasn't really made much progress is because it does have a business use case. We are literally doing just bespoke solutions at this point. These are all custom built for very particular use cases, with a lot of labeling effort happening on our front, uh, not relying on open source data much for this particular problem.
Yes.
So coming to NLU, truly transformers and Hugging Face and all that has really changed the landscape. The neural approaches truly allow for jointly optimizing multiple tasks within the NLU umbrella. Makes the models better and also makes managing models better because the same model can be used for multiple purposes. Life gets easier from an ML ops standpoint when we do that. Even though there is a lot of success with these all neural systems, there's still a place for hybrid approaches where you can still have rules and neural models coexist and really do a fabulous job. Uh, One such example actually is because of what Nishant mentioned, where if the entities are split across turns. So let's take an example at a contact center where the agent said, "Could you please confirm your phone number?" And I started off by 425, 636, 7297. Oh, you meant 7297, right? So this is how the conversation goes. Now, how do you take each of those number sequences that came along, stitch them back together into a 10-digit number, then run it through your named entity recognizer to finally get to the phone number? That's a very hard task. And in this flow example that I just gave, I did not even repeat. Many times the customer will say 425, agent will say um, 025, let's say, is what the agent repeats, and the customer say, no, 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 it's 425. you know that's it. You throw any normal NER at it and it'll just get that number as 425, 425, 63, whatever, right? So that's one of the challenges we deal with on a daily basis. And for now, we are relying a lot on rule-based systems to figure that out, because there is something called dialogue acts that that doesn't get as much mention today as it used to in the past. But you can detect these restarts or corrections or hesitations or partial words. All these things, these are all dialogue acts which we can detect either through speech or through text, and use that information to trigger certain rules to either you know overwrite previously filled in information or edit previous information and so on. So that's what we are using today. But I've seen some really interesting papers coming from Apple and Amazon recently on how even that can be learned by neural networks to be explicitly robust, or they're explicitly taught to be robust to these speech acts. So you'll have a speech act detector that will feed information into the your neural net, which also does the prediction. So if an act called error correction happens, the network knows that I have to remove the previous three words that I just detected, update it with something else. So there are I think that's very fascinating to see if we can really solve that problem, because then you can remove this reliance on high accuracies for ASR. Many times just the vocabulary also, right? In ASR, if someone said 4 to 5 with big pauses in between, a lot of ASRs would just hypothesize as 4 and the word TOO and then fine, FINE, let's say. And then a whole bunch of number sequences happen. You could technically go to the phonetic level or your n-best lists, or however you want to look at it, and figure out that this was a larger number sequence, and the context is just so strong that the word fine has to be changed to 5, and the word TOO needs to be changed to TWO. And we can teach systems this. So that's also another active area of research where robustness to ASR problems are explicitly taught or built into the models.
That's very useful. Yeah, those examples were really hitting the core of the problem, as I see.
Okay, I'll skip through some of these because I do want to, and I'll share this. These slides will be available, so
Sure.
people can look at it. Yeah, I did talk already about context and personalization, how we can use prior history to bias ASR inappropriately. So coming to ASR, what the state of the art and the advances, as we mentioned, Kaldi and other open source tools, there are just tons of deployments. There have been many companies built on Kaldi technology, very well defined recipes on what to do for various languages, or when the amounts of data are low or high, what to do with them. And the good thing with any of these open source tools is they've been around long enough that you know what the compute needs are. You can plan your deployments around that upfront, rather than some unknown thing where especially with the end-to-end neural systems, which are examples here that I quote, and I'm sure there are many that I'm not paying attention to, is ESPNet is one, NVIDIA's Jasper is another, Mozilla Deep Speech, Facebook's Wave to Vec. There are many such end-to-end neural systems do a fabulous job. The big difference between this and Kaldi is with the end-to-end neural systems, even though the training time can be just very, very expensive, you need beasts of machines to deal with it, and a lot of data. The inferencing time is a lot cheaper. I mean, in a lot of cases on our smartphones now, we have end-to-end neural systems doing speech recognition on the edge. That is possible because of the neural systems themselves, and they can use the GPUs on the fly and so on. So there are a lot of advantages with the end-to-end neural systems. The other nice evolving area is where end-to-end systems can be used to optimize for something other than word error rate. So, one of the challenges that we have is in our rule-based or I should say hybrid system, where certain rules also have trigger because of keywords being detected. Us blindly trying to improve ASR on word error rates makes no sense. We should explicitly try to teach the system to be better at keyword recognition at the expense of other non-content bearing words, rather than just getting hung up on word error rate, which is obviously a great metric, very general though, it's not specific to your problem. So how do we do that? That's also an active area of work, that the end-to-end neural systems are a lot more viable to tune to those new metrics. Lot of data availability is there for voice now, not across languages, but I think it'll happen sooner than later. For example, the Mozilla Common Voice project, lots of data available for many languages. At least it's a good start, if not necessarily for solving all your use cases where you may need telephony speech or you may need very specific type of speech. This at least gets you to a basic level of accuracy quickly, and then you can do the optimization for your particular use case. So that jump starting is possible now. Libri speech obviously has been around for a while. The high quality closed captions from online videos is a great source. A lot of people are starting to use that. A lot of Indic language data is available now on the web, through a lot of university and government consortiums. For the language model side, the gigaword corpus is a great source, which obviously plays a big role, especially for the hybrid systems like Kaldi. Yeah, and also a good trend or a change that I'm noticing is just the sponsored ASR challenges. These are just great for pushing the envelope on state of the art. It's also definitely helping people start to look at low resource language research. Data availability is not a challenge anymore for people to get into this field from other fields. People who have worked in other areas but have kind of stayed away from speech because of lack of data now, don't have that excuse anymore. And then, these challenges are also encouraging multilingual systems, which, if you think about it, even though the market for most companies in conversational AI is still the US market, which means English. The population wise, the world is mostly multilingual. Europe is full of multilingual speakers. For example, I mean, they take a day trip from France to Germany for work, let's say. They call from Germany into the contact center but want to speak in French. Well, systems have to be capable of doing that, and that's something the EU always insists on, is multilinguality. Similarly, in India, we need to have that. Uh, Here, just because of the urban population being a lot more conversant with English, even though we speak our native tongues, English has really made serious inroads into our daily vocabulary. That puts a challenge. There is nothing called Hindi anymore, it's English. There's no, and whatever we want to call the Telugus and the Tamils of the world, or the English forms of them, there's just so much English in it that the only variants that we as a company, Uniphore, is wants to release are something with a lish. And so that's also, the challenges are really helping get that research onto the right path. So with all that progress, then, so what's the problem? Audio quality still remains the problem. Domain knowledge. When I say domain knowledge, there still aren't corpora that are, let's say, banking specific or telecom specific. The industry specificity on data sets is lacking. That's where people again deviate from the switchboards of the world to data that they own. They don't want it to be, excuse me, in the public domain, because that's their edge. And we are Excuse me, I'll just take a quick sip.
Sure. No.
Yeah, so the domain knowledge is still very close to the West for most industries.
You can
Accent,
pause. Do you want to pause for a moment and then?
yeah, yeah. 1 second.
Yeah. So audience, how are you doing? We are taking some of the questions, but yeah, since this we are running a little bit low on time, so uh, if you have any quick questions or comments, please uh, write in the chat box, and either at the end or we will take that up.
Yeah, I'm back.
Yeah.
So,
Okay.
yeah, I think the challenges that are still stopping full-fledged adoption of ASR at scale today are audio quality. Quickly, when I say audio quality, anecdotally, just one of our customers, they still give us data as MP3, um, and that too at as low as 12 kbps. So from a spectral standpoint, basically you don't see any information beyond 2 kilohertz. Now
Yes.
think about how do you differentiate the fricatives if you get data like that? And that's one of the reasons why in this day and age, instead of treating ASR as a black box, it's really important and necessary to pay attention to the signal processing side as well. Because if you didn't look at the spectrogram for an audio file, then you wouldn't appreciate why do we use MFCCs in this day and age, or why does or what does this 12 kbps translate to in terms of the spectral quality, which will eventually hurt ASR performance. We can't even communicate to this to our customers or our businesses if we don't understand the signal side of ASR. So it's important for students in this area to definitely keep that as a priority. Is get that signal fundamentals right. In spite of the advances in neural networks, you will eventually have to debug some problems uh, where knowledge of signal processing will play a big role.
Yeah, and that's again a bold message to be played with speech, and again with images also. You have to go back to fundamentals of how images and speech is generated, and understand the signals better. Yeah.
Yeah, the other point I want to talk about just briefly of all these other issues is context unawareness. Um, Today when we get a call, between two humans, it's a stereo call. You have channel 1, channel 2, or the left and right channel. You process each of them with ASR. There is absolutely no connection between the two channels as far as ASR is concerned. It's just two signals for it. That just seems like a big gap in what the potential can be. For example, agents, especially in a contact center space, are trained to reconfirm what the intent of the call is. So if I call and say, I want to reset my password, immediately the agent will say, sure, I can help you resetting your password. The fact that they said sure and agreed to an intent called password reset should mean a lot to what the rest of the conversation is going to be about. We literally just ignore all that information and just assume that NLP is a different problem. Therefore, let's first get our text right and then get NLP to do its magic. Well, reality is this happens in parallel. Even as humans, I hear something, I interpret something. Based on that, I bias my interpretation that is going to follow. If I do that as a human, there's really no reason why we can't build ASR systems that are a lot more context aware, where we can infuse information even into end-to-end neural systems, where intent plays a part of the input feature, intents and entities. Um, for example, in the bot world, when the bot says, please confirm the last 4 digits of your social security number, the fact that it requested for something that is going to be a set of digits later should be fed back into ASR, very aggressively, so that it doesn't make this mistake of hypothesizing the word TOO instead of the word TWO, when you know that phonetically, even though they are the same, TWO is the right thing to do there. There are advances that are being done, with speech priming in Azure, and then context from or boosting that Google Dialogflow does. Still, I think they are still in their nascent stages, and it's a very naive approach that is being used today. There's a lot of scope for research in that, building context awareness to ASR by infusing information from NLP. Uh, and then something that often forces us to hit the brakes with ASR deployments generally is still compute needs. We just can't go to a contact center and say, I'm going to give you great insights, but it's going to cost you, an additional $5 an hour. That just doesn't fly. So then what do we do? And that's why we need to pay attention to not just think about the biggest, baddest neural network that is out there that I want to solve the problem. You should probably start there, but quickly understand what your business needs are and make a decision on what impact does this have on my compute infrastructure. How can I use a slightly low grade equivalent of that transformer to do the job instead of this thing? Or can I do distillation? Can I do transfer learning? Can I do something else where I can still fit within the constraints of my compute infrastructure? The other thing that always plays a spoil sport is latency. In real time, when I want to give assistance to the agent, if my insights, which is a combination of both ASR and NLP, if that happens even, let's say, 4 seconds later after the fact, think about how the user experience will be for the agent. So the agent just said, the customer said, I want to reset the password, and the agent said, sure, I can help with that.
Oops. I think we lost Aravind. Yeah, we're a bit tight on time today, unfortunately. So I'll request everybody to post their question on our LinkedIn event page, and then I'll request Arvind to answer those questions. Hi, Arvind. I think we lost you a little bit.
Is it better now?
Yeah, now you're back. Yeah, I think the connection got disrupted.
Is the screen share still happening?
No, it's not there. And we are running low on time, so it's only 5 minutes in the session.
Yeah. So we'll quickly, get to what I, a summary at least.
Yeah.
Data, one of the things, and you guys, can definitely comment or email me on what you think about some of the things I talk about. Data definitely is a primary obstacle. Yes, the privacy and all these rules from GDPR and the CCPA, PCI, PII, how does this impact what we can and cannot do with customer data? Just challenges everything that we do on both ASR and NLP. One thing I just wanted to talk about before I end it is just the accumulation of errors. As you saw, the very first slide, we talked about conversational AI, and in the word cloud, we saw accumulation of technologies, right? Which means there are just so many technologies that come together for conversational AI. For example, when you have language ID system and that you get it wrong, think about the impact of that on the ASR downstream or the NLP. Someone speaks in Hindi, you detect it as English, you transcribe everything with your English model, and now you try to gain insights, and obviously that's a disaster. Speaker diarization, you may think, that's a solved problem, but if you get it wrong, the impact on NLP is just tremendous, because a lot of NLP algorithms work on who says what. When the agent says something or the customer says something, if we interchange those two, the meaning and the tracking that we have to do with entities and intents is completely lost. VAD issues, if there are VAD issues and you say something and the bot doesn't stop speaking, it continues with its TTS because VAD didn't trigger. Imagine that experience that you'll have. You have to stop speaking. Again, they finish saying their prompt. Now you have to restart. Now you lost your train of thought. As an end customer, the user experience is just horrible. And then obviously ASR and NLP issues we have talked about. So overall, I feel like we have made just tremendous progress. The future is definitely bright. The machine learning advancements are just mind-boggling, I would say. How we apply that to these specific problems is up to us. There will always be progress, but running after the shiniest the new algorithm out there will only waste everyone's time. Especially coming from industry, I appreciate that a lot. We have to decide on, in some sense, on what are we going to hitch our ride to. If you want to go the transformers route, definitely do that, but don't jump to the next new thing that's going to happen, at least for a year or two, because it takes that much time for you to actually incorporate these technologies into a real product, get feedback from the real world, and put it back into improvements and so on. So anything less than that, if you keep switching between technologies, you're just always in first gear. You never get a chance to get into your fifth and sixth gears. Yeah. So overall, yes, the growth of the compute power and these advancements in machine learning just make me very hopeful for what conversational AI will be in the next few years.
It's very good. Thank you so much, Aravind. This has been a really resourceful. We've covered so much ground today, right from the history to all these different aspects of conversational AI and ASR. I mean, for people who have started playing with Hugging Face models, it must be an eye opener. There is so much detail involved in every step here. And thank you so much for taking us through the whole spectrum.
Thank you. Thanks for the opportunity, and I'll share this
Yes.
slides with you, Nishant. And anyone you have questions, please feel free to email me, or on LinkedIn you can always ask me questions. Because I skipped through a few parts, especially the data part. I myself am very passionate about that. I come from the school of thought that data is king. It's as they say, is the new oil of the machine learning world.
Okay.
So
we have the LinkedIn page for the event. I'll request. We were not able to take many questions, so please post there, and I'll request Aravind, or I'll point him to get them answered. Yeah, we should have planned for a little bit more, but unfortunately
we can do it again. Probably
yes, that would be awesome.
Later we can focus more on a very specific aspect, and I can do on.
Yeah, the treasure trove of information that you have about this whole field would be, I think, beneficial to many. So thank you so much again for taking time to prepare the presentation and share your knowledge with us. And I hope everybody in the audience enjoyed the talk. You can show us with a like. Yeah, thank you.
Yeah. Cool. Thank you. Thanks. Hopefully it was useful and beneficial, and we'll encourage people to continue thinking about all the areas of research that are possible.
Yeah. Thank you, everybody.
Thank
you.
Yeah.
Thanks, Aravind, again. Yeah.
Bye.